Hello everybody and welcome to today's presentation, Discussion and Demo, Machine Learning with True Real-Time Decisioning, brought to you by VaultDB. I'd like to introduce you to our presenter, Doug Haurigi. Doug is a Senior Solutions Engineer at VaultDB. Doug has deep knowledge and experience in technical consulting and currently resides in the Dallas, Texas area.
All right, thank you very much. So thank you all for attending today. So where do I start on our story here? Well, given the proliferation of today's interactions from users, the way that we gather insights to engage with users has changed. In the past, we would gather information from communities against a few devices like TV watching habits, and the information would be tailored to a wider audience. But today, with the explosion of the devices and the proliferation of all of these devices, the way that applications are designed are now very individually focused. And the rate of this insight gathering is speeding up for a variety of different needs. If these insights are not gathered quickly enough, then the information obtained will quickly become obsolete. So our data landscape is rapidly changing. At the present, there is more information that gets created in the last 2 years than in the entire history of the human race. And only half a percentage of all of that data is ever analyzed or even an action that's taken upon it. In just another couple of years, we'll be generating a massive amount of data for every individual every second that's on this planet. And in just another few years after that, there will be billions of devices that will be connected all over the world that are going to be collecting and analyzing data that needs to be shared, right? So we have this competitive advantage. The organizations and the technologies that are allowing us to operationalize and gather those insights, the companies who are able to make best use of that before that data becomes perishable will make them the most valuable businesses around. As Michael Simone, Managing Director at Citigroup, one of our customers that we're engaging with, has mentioned to us in the past. So I believe that there will be a panel question here that will come up regarding your current machine learning projects, if any.
And here are the results.
It seems that a little over half of you have no project defined yet. Maybe about slightly over a quarter of you are gathering and preparing a project and information. And even some of you, a little over 10%, are actually evaluating an existing machine learning models and going through it. And some are actually even beginning to deploy this in production. So that's excellent. All right. So what makes us VaultDB unique from others, right? That's the primary question here. To start off, we'll go over a little bit about our history. We originated as the brainchild of 2014 Turing Award winner, Michael Stonebraker. You may be familiar with some of the other technologies that were founded by him, such as Ingress, Postgre, Vertica, Tamr, Streambase, as well as VaultDB. So VaultDB was created to provide true real-time decisioning capabilities that many industries need. In particular, these would be like verticals like financial services, would be advertising technologies, telco organizations, and many others, right? So the technology was designed to be this in-memory system that has a shared nothing architecture that has the ability to be virtualized and containerized and orchestrated with Kubernetes. And we're able to have a myriad of connections to data warehouse systems like a Hadoop, a Vertica, and be able to move data back and forth, as well as export and import from other data sources. We do have the highest recorded benchmark from a performance perspective of any in-memory database that is schema bound. we have set up and able to reach for CRUD-style operations up to 6 million transactions per second on an individual cluster. And if any details regarding that, you may be able to ask those questions at the end. I'll be more than happy to provide some of the information on regarding that. So you may see some of these logos here. You may recognize some of them like HP, Flipkart, Mitsubishi Electric, OpenNet, gaming companies like King.com. So all of these companies are needing to be able to operationalize and gather the insights from things that are happening right there, right now, in real time, and sometimes in as quickly as 250 milliseconds time to actually make a decision. So for example, if I'm talking on the phone and all of a sudden my data plan is starting to run out, I want to be able to be alerted and notified that before I put the phone down so that I can actually get a value from that information and be able to make a quick decision right then and there, right? So these applications that are now being designed that require this speed, they're all adapting and they're all needing this capability, whether it's fraud prevention, whether it's trading platforms, risk management platforms, OSS, BSS systems for billing and policy management from telcos, all of the sensor data or time series data that is being collected from IoT or connected city solutions, advertising technology to be able to track all of the different click streams, be able to do things like prevent bots from abusing the clickstream systems, personalizing this data with all of the insights that a user is performing. So that way, if I'm watching a YouTube video, I'm able to get that information tailored to me and have a video or song presented to me based on my interests, but based on perhaps even my interest from the last few minutes that I've been clicking through different music videos, for example. So all of that information is very important to make a decision as quickly as possible before it becomes perishable or stale data. So VaultDB, as I've been talking about, this very fast, very flexible system, plays in the fast data layer. That means it's the operational side of things where you're able to process and interact with users and actually be able to provide information in a real-time fashion. This means if I'm going to a terminal at a store and I'm swiping my credit card, I want to be able to, as I'm swiping that credit card, go through a series of processes, such as I'm going to check based on my purchasing habits, my location, and everything else, other features that may be identified. I want to make sure that that system is quickly able to churn and compute that data so that I can be able to get my authorization approved or have it detect that I'm potentially not the individual making that credit card purchase who is authorized to actually make that purchase. So all of those are in this fast data layer as compared to the big data layer. So when I'm talking about machine learning in this conversation, I'm restricting it to the operational layer, the fast data or true real time, because that's where it matters, right? You're trying to analyze the information from raindrops of data as they're being streamed into the system, right? So VaultDB is this very fast, very scalable system that allows you to ingest a lot of information through bulk loading of information or streaming this data in a secure fashion so that you can have PII compliance. Be able to do all of these analytics in real time, what we would term as operational analytics or true real-time analytics, and then have all that be at the highest level of ACID compliance possible, but do so with the highest performance and highest sustained latency that you potentially can get from a cluster deployment. And then be able to, yes, quickly export that information out, generate things like alerts, triggered alerts on different events that are occurring within the system, and be able to execute an action in real time, right? So this gives us our competitive advantage, and because of this, we have been deployed for mission-critical solutions at Fortune 500 companies, at large and small organizations, to be able to actually deploy out and execute a true real-time application or use case. right? So now let's talk a little bit about the Vault platform. We talked about what kind of makes us unique in the space, in the database space. Now let's actually talk about the nuts and bolts of the VaultDB platform, right? So here you have a typical, reference deployment architecture that has high availability built in, disaster recovery through our cross data center replication, so we can move data back and forth. Integrations with systems through a REST endpoints or other connectors like a JDBC or our smart clients, be able to then execute all of our different complex rules that are actually running as precompiled Java-based stored procedures at the database level, thereby giving you the most flexibility and the ability to leverage a partitioning system within the VaultDB platform so that you can reach the scales that you need to do for your operational data use cases. And then, of course, moving those information back and forth into a data warehouse so that that data warehouse can then execute different things like the machine learning process that we'll go through in a demonstration in later after this conversation. And then those insights can then be fed back into the system so that we can actually leverage that historical data within this VaultDB platform and be able to do this decisioning that we're talking about. Right? So in a nutshell, VaultDB has integration capabilities to be able to load things in a bulk fashion. So for example, comma separated files, we have the ability to execute a one-time Kafka load or a continuous Kafka native stream integration, as simple as configuring an XML file and putting in the topic and the broker, and that's all you have to do. So it's codeless capability to actually integrate Kafka, configuration driven. JDBC, Vertica connectors, and we also have an API that you can create a custom connector that can be asynchronous or synchronous. So that way you're able to take advantage of multiple threading and instancing capabilities with these connectors. We also have ODBC, HTTP connectors, as well as I mentioned the smart SDKs, whether they're in Java, Golang, C++, PHP, Python, you're able to communicate to VaultDB. Exporting, same thing. We're able to actually move data out from VaultDB in the same speed, same fashion, whether they're JDBC connectivity, Kafka connectivity, RabbitMQ, HDFS. We also have an API to actually export the data in the same manner, right? Synchronous, asynchronous capabilities, and be able to move that out to wherever you would need to. So as part of the ability to import and export, we're also able to have this unparalleled querying capability or querying performance with ANSI SQL 92 compliant query language. So everybody who understands and has worked with Microsoft SQL Server, Oracle, or MySQL leveraging VaultDB from a querying perspective is the same way. We have the strictest ACID compliance of any platform out there, any database platform. We have the ability to replicate our data via cross-data center replication, not just as an active-passive way or unidirectional, but bidirectional, active-active. Things like geospatial query support are built in, and numerous hundreds of functions to perform different things like aggregates or math computations are in place. Just some example metrics, right? So a single node, we were able to do 53,000 transactions per second for CRUD operations, allowing you to be able to have 40 times better throughput than, say, the a traditional relational database system like a MySQL. And then as we are able to cluster and we have automatic sharding and our partitioning strategies in place, we're able to scale out. As an example, 12 nodes would get us 500,000 transactions per second, and we would have our sustained latency would be linear in nature. So as data keeps getting added in, we'd be able to handle that with no problems. Right? So as we talk about our VaultDB platform, we like to think of these as different entry points or solution sets. So VaultDB is able to be configured, for example, for stream processing. If you don't need to have persistence, you're able to ingest very large scale amounts of data with, say, Kafka, and be able to move that on a continuously low latency, be able to leverage store procedures, be able to leverage all that event decisioning capability. But if you need to do things like, you know what, well, I want a caching solution, you're able to do a smart cache system where you can configure VaultDB in a key value scenario, execute and run JSON-based ANSI SQL92 compliant queries to access the JSON data and be able to move that data back and forth. If you need the full-fledged system of record, then VaultDB is able to do that with full immediate consistency and persistence in place. If you need to do things like recursive common table expressions for distributed ledger solutions, then you're able to also use that. Again, at the end of the day, VaultDB has these different configurations that are designed to be able to fulfill and solve certain problems that you need to have done with the platform. And so you're not stuck to, okay, I have to use all this functionality or not. You can actually tailor it through configuration to actually be one or the other. And so whether you need a document store or you need a schema-bound relational system, both are able to actually leverage things like machine learning and Java-based store procedures and custom user-defined functions that you're able to then do things like very advanced math, like linear regressions, doing scoring systems, but doing all of those things in millisecond level time. That's the key. And at scale, right? So in this example here, we're looking at our real-time decisioning system for fraud prevention as part of this conversation and using machine learning to be able to execute these models. So our smart relational system has a full persistence in place. We are leveraging JPFML, but for the fast data layer, right? So I do want to make a distinction of that. Using PMML and machine learning for the fast data layer is still a novel approach, right? This is what lets you do things like real-time fraud prevention, not just detection. You're actually able to, in mere milliseconds, make a decision, have a score based on, hey, Joe Bob used a credit card in Boston, but I live in Dallas. What happened? Hey, you know what? Because of the amount and because of the location and the store and all of these features that I've baked in as a bank, I'm going to say that's fraudulent. So pause that, freeze that transaction, send Joe Bob a text message saying, did you make this transaction? And let him be able to respond yes or no. And then be able to then rerun that transaction again if that indeed was Joe Bob running that transaction in Boston. And all of these different things are able to then execute like a webhook back to the payment gateway system and say, yes, approve this transaction or not. But all of those things have to happen in real time, right? So as I've been talking about this fraud prevention example, right, this is what we're going to demonstrate, right? We're able to then use machine learning within VaultDB, but we're able to do it at scale with very, very millisecond level latencies. So you have these different mathematical model types that you're able to support, like clustering, linear regression, decision trees, vector association rules, and so on, right? And be able to then have a PMML emulation to be able to load this stuff up, load your model, and your model could be, as simple as a couple hundred kilobytes, which just has maybe 5 features or columns, or it could be gigabytes in size. There is only one payload hit there, and that is whenever it instantiates and pulls that PMML model that was defined. Once it loads into memory, then the processing speed is, again, in milliseconds, right? So how does this normally work in a production environment, for operational needs? So traditionally, you would generate your first model from a historical data set, whether it's Hadoop, MapR, Vertica. We were able to support all of them. You're able to then do things like execute with PySpark in Python and extract your features and be able to do so without having to be a data scientist. That's also the key values that VaultDB allows you to execute. So you train these PMML models. You then feed this and load it into, in a dynamic way, into VaultDB. VaultDB then receives this information, it loads the model, and then as incoming data continues to stream in, that model starts making decisions. And those decisions then start having some sort of an action to them. Those actions can be scaled out, again, to tens of thousands, hundreds of thousands of transactions per second with those sustained latencies, and be able to do so on an ongoing basis, always on, always available. All right? So we're going to go ahead and discuss now our actual example. As we've been kind of drilling down, we looked at the problems that we're facing today. We're looking at, okay, how does the VaultDB platforms allow me to start solving those problems? And now we're going to drill down into a specific problem and how VaultDB is able to solve that problem, leveraging machine learning, right? So our objective was simple. We wanted to be able to automate the fraud detection process, right? Before, it was a series of rules, conditional statements, if you will, as events to be triggered. So if user was in Boston, if it was at midnight, if it was maybe in a different part of town that normally would not be close to the airport, for example. So you're using a whole bunch of series of features or columns or attributes that would then define how you set these up. Except the problem with that is that that's very time consuming, and those all require a much heavier involvement from business. Whereas if you're able to automate this process, those thresholds now start to become dynamic, because now as data is being fed into Hadoop, Hadoop starts changing those values. So now your average spend may not be $10, it might be $12. So therefore, when those features are extracted and generated into a machine learning model, those values will now dynamically change. The math and the coefficients will shift, thereby giving you that dynamic ability and automatic ability to continuously have your fraud detection and prevention process in place, so that you can do things like accepting or declining credit card transactions. And then again, for the whole purpose is because that historically has been big data layer solutions. That means, hey, let's have an analyst run these machine learning or neural network processes on my data warehouse, and let's just get a report. Well, that's great, except that is after the fact. What if we can do this while things are happening? And it doesn't just have to apply to financial services. This can apply to anything that you're needing to do a check or a balance on, and then raise an abyss in real time, right? So for example, if I'm playing a game and I'm playing Candy Crush, for example, and I want to be able to, beat some level, maybe after about 5 hours, the system has detected that I've been playing for that long and have not been able to pass a particular level, and now it pops up a question saying, would you like to advance to the next level for $1? And I might be inclined, and I say, yeah, sure, why not? So you have a variety of ways, and it's not just limited to one particular thing for machine learning, right? So the goal, again, of the demonstration was to be able to capture this information, make a decision in milliseconds time, and then be able to have a nice way to deploy this out. So the way that we accomplish this with VaultDB is in the following reference architecture. We're able to generate using SparkML, PySpark, or R as well, but PySpark seems to be the best, most efficient way to be able to do so. We're able to define the features within the pipeline generator and be able to then extract and fit that model into a PMML or XML file. This XML file will then be shipped over to VaultDB, loaded in a jar, and then loaded up in memory into the VaultDB stored procedure. So therefore, it is available at all times the moment that it's loaded. What's great about this is none of this requires you to run through this loop forever or based on whatever intervals that you need to sync up or update your models on your real-time layer and be able to then continuously run this analysis. Now, there is a small hit. The first time that this model gets loaded into memory, there might be a few hundred milliseconds hit while it's loading it up. But after that, it drops down again to the millisecond level speed. All right? So again, the power of VaultDB, the value is that you're able to leverage Java. You're able to execute ANSI SQL 92. And we are leveraging the power of PMML to run through all of those decisions instead of having to create a list of hundreds or thousands of conditional statements to match our our sets of data that we're trying to match. So here's an example of a tree procedure class that is actually executing the model and passing in the features or the columns. Now this code here automatically gets generated. So if you're thinking, oh, I have to write all this code, the answer is no. This gets generated as part of the modeling process when it gets loaded into VaultDB. Right? So normally the way this works is we generate our model, and the way to do so is be able to define a formula. The formula has all of the columns that we're trying to use to actually execute some sort of computation. We then choose, in this case, it's a classifier. We then organize this information into a pipeline. So we stage it, and then we fit that pipeline into a file. And then we write that file out. That file then gets moved over to VaultDB, and then it's loaded into VaultDB to be leveraged and used. All right? So how do we do this? We have a few dependencies leveraging JPFML as part of our project that get loaded in. We are able to, so there's a JPFML Wrangler that actually executes and regenerates that class file that I showed you as the first item that is able to dynamically be compiled. Once we have this class that is generated, this becomes our audit tree user-defined function. So this function then gets registered so that we can use it in inline SQL statements in VaultDB, which allows you to have very powerful capabilities because you are able to do anything that you want in these user-defined functions, any kind of computation, and be able to then call them out and be leveraged within VaultDB. So once we have all of this stuff defined, we register and create our function. We create our store procedure that leverages this information, and now we're able to query this information, such as this example here, and be able to actually get an output. A decision would be the. So now let's shift to the demonstration. Let me open this up. Let's see. So I've got Kafka loaded here. So I've got my Zookeeper. I've got my server. And now I just need to run my producer. Oops. There we go. All right. And then I'm going to run my consumer here so that we can validate that we are in fact sending data through our Kafka stream. All right, great. Excellent. Let's load up our, let's see. Let's actually go to our VaultDB. All right, so we'll load up our SQL command line, and we're set. All right, so let's start copying some sample data set. So in this scenario, I've got one here I've selected, 6903317. Just to validate that. Let's make sure it's not in here, and there isn't. All right, so let's go ahead and paste it. So we're going to showcase here how we're taking an incoming stream and moving it into VaultDB with ease. All right, so we have, let's double check our consumer. Oh, no broker. All right, what happened? Oh, there we go. We have to start our broker up. All right, start our server. Excellent. All right, there we go. Now it passed it in. Perfect. So we should now have it in place. And there it is, 693317 with our decision as classy or classification and how many times has it's been fed through. So if we were to feed this in again, here we go. Oops, not the right thing. Let me copy this again. All right, so now as we go through, this should have a second item in place. Yep, 2. So as you're able to see, this is running in milliseconds level time. A decision is actually being generated and processed. To showcase a little bit, here's the DDL that is actually executing the process here. So this import audit data is the one that's this function that, or store procedure that gets executed when the stream is receiving, or the producer is receiving data, moving it into VaultDB, and then this is able to then execute a couple different things. So I'm upserting into my audit data, and I'm binding my values, and I'm also then inserting into a decision stream export table, a aggregate of my data. And what's great about this is this decision stream export table allows you to be able to hook up an export of this so that you can actually not only are you eliminating the old store and query methodology, but you're actually able to export this in real time over to another Kafka to produce another Kafka stream, so that you can execute this decision score to a payment gateway and say, you know what, deny this charge. And then the second time you might have gone in there because that SMS text message will have said yes, and it goes back to VaultDB. There's now a column there that defines texted or not, yes. So that's another feature that could override the actual score because based on a timestamp. And now when you pass this back in, the classification will be 1, and now it'll allow that transaction as an example. So this concludes the demonstration. I will now allow any questions that anybody may have. So let's shift back to the presentation here. All right.
All right. Our first question is, does VaultDB integrate with APIs?
Yes. So we have a series of different SDKs and different languages, .NET, Java, PHP, Python, C++, that is able to integrate for any of the applications that you need to develop.
Great. Our next question is, how does the solution integrate with Hadoop and real-time data sources?
So we have our connectors that are able to connect directly and natively to Hadoop to be able to pull things out. Depending on the data storage that you may have, there might be some things like serializing the JSON data and then having that be converted into rows and columns and rows. Or if you're leveraging VaultDB as a document store, then that becomes a lot easier because then at that point, we're storing the same payload or same serialized data into VaultDB. So connectors are the way. We have a Hadoop connector that allows you to do that in a synchronous or asynchronous fashion.
Great. The next question is, does PML/JPPML support any model? And does VaultDB support all the models?
So we do support all of the mathematical model types available within the PMML standard. And as long as that PMML is adhering to the standards defined, we are able to leverage and load those models up. Not only are you able to do it the way I showed you through code, but there's actually a command line interface in which you're able to just simply do a command where you're loading the PMML file, and it does all of this code stuff that I showed for you. And then at that point, you're just able to leverage it and use it within your stored procedures.
Great. Our next question is, what are the requirements to run VaultDB?
So the hardware requirements are dependent upon the sizing of your project, but our base reference architecture is a 3-node setup. So this means 3 different environments have to be created so that you're able to leverage the best of high availability or persistence, what we call a replica factor or K safety, and be able to set these up. In terms of specs, we start off recommending for production at least a quad-core or 8-core, again, depending on the metrics that you need to obtain and your latencies, those node counts may increase.
Great. Our next question is, does VaultDB have any in-cloud/SaaS versions?
Yes, we do. We have our partnership with Amazon, so we're actually on the Amazon Marketplace. Both you can either set it up on the Marketplace and pay a transactional cost, or BYOL, bring your own license and load it up on Amazon as well.
Great. Our next question is, can queries be written dynamically by the end user on the data?
Yes, absolutely. We actually have a couple use cases in which a lot of the folks that we had that had learned Oracle PL SQL wanted to be able to leverage that knowledge and have that information be seamlessly passed down. So there were customizations that were made that allowed us to be able to execute these PL SQL statements and reconvert them into VaultDB queries and VaultDB stored procedures that could then be registered. So that way you're able to dynamically update VaultDB without having to actually touch the system.
Great. Our next question is, how does VaultDB help speed up the time to deploy models to production? So
VaultDB is, one of its features is the ability to take that PMML file, as we saw in the demonstration, as we saw in the presentation, and actually load that in side by side in the store procedure and be able to do that without having to go offline at any point in time. There is no other platform for real-time data and real-time decisions that need to happen that allows you to seamlessly be able to do so and be able to continuously repeat that process in a scalable fashion and without going down.
Our next question is, do we have the documentation on generating JPPML and how to integrate it to stored procedures?
So generating the PMML, there are different ways that you're able to do so. So you can leverage Spark M libraries and use things like PySpark so that you can actually execute via Python your formula and then stage that formula into a pipeline and then fit it. So you saw the list of the different mathematical model types. You're able to use any one of those within PySpark or Python code and be able to fit that in and execute the generation of your pipeline that gets staged and then fitted into an XML model. Then, once you do have that, You're then able to load that file into VaultDB, and there is a Java PMML engine as part of VaultDB that actually instantiates or loads that model into memory so that it can be leveraged and used as a user-defined function, for example.
Next question is, does VaultDB provide support for data collections or data analysis?
So we do have support for the data analysis, absolutely. In regards to the data collection, I would need to get a little bit more clarification from the individual who asked the question. But we are able to integrate, for example, to BI tools with JDBC or ODBC and be able to actually do things like dashboarding or generate reports using those tools that are accessing VaultDB.
Great. Next question is, does VaultDB support JSON data format?
Yes. Yes, it does. If you want to leverage VaultDB as a caching solution, as an entry point, say for read-only use cases, then you are able to configure it so that VaultDB is a key value store, but yet you have all of the great benefits of a relational database system. That means you have the querying capability, you have the ability to use the Java store procedures, and you have, if you need it, ACID capability, not just against one document, which is NoSQL's limitation, but against thousands of documents, but with the strictest isolation, right? Strictest ACID compliance.
Next question is, does VaultDB support AutoML?
So as we are expanding and we're starting with PMML, we are actually looking at the different machine learning models. So if there is an interest in that, definitely we'd like to speak with you and see how we might be able to support you with those additional machine learning models. In a nutshell, once you integrate one, integrating another is going to just be that much easier. So we already have the PMML standard. I would just say just contact us and then we'll work with you.
Great. The next question is, what database is VaultDB built on?
So VaultDB is built on it's a custom database that was designed and founded by Michael Stonebreaker. So it's designed to be able to be this in-memory system that allows you to have automatically sharding of your data or distribution, partitioning that data against tables to maximize the system's ability to parallelize the querying of that data. So it is a proprietary system, but we do provide an open source version of VaultDB.
Great. Our next question is, how is the model loaded by VaultDB? Does every site receive its own in-memory in copy, or is there one shared copy per node?
So great question. Today, you're able to employ whichever way you would like. So you could store it as a single copy on a SAN, on a physical storage system, so that it can be loaded that one time. So yes, there would be perhaps a slightly additional payload hit in loading that up that one time. Once it's in memory, it stays in memory for the duration of the entire session that VaultDB cluster is running. Alternatively, if you want to, you're able to then load it into a table as a key value store. So your PMML is actually stored in the table, and yes, it would then at that point be replicated into every node so that it's always available as each node would need to have access to that PMML data. Especially if you are doing refreshes of that PMML file on a continual basis. So in the case of financial services, they may have hundreds of features defined, and they may be adjusting certain criteria of those features, or the data itself is changing so rapidly that they need to deploy out, PMML files perhaps as quickly as hourly.
Awesome. Our next question is, referring to CAP theorem, where does VaultDB stand practically? CA, CP, or AP?
So regarding the CAP theorem, in an intra-cluster scenario, that means one cluster, VaultDB would be able to have the consistency and the partitioning. Now, if you want to have availability as well and partitioning, then this is where you're able to then leverage cross-data center replication. Like a lot of the different NoSQL vendors have done, technologies have developed, we also have our ability to have the full-fledged of the CAP theorem. That means you're able to have consistency and partitioning in one cluster, but then have your availability against multiple clusters that can be deployed in different data centers. This gives you the ability to have, yes, an eventual consistent model between two clusters, but you will have availability built in as well. So this allows you to be able to fulfill all three different capabilities of the CAP theorem, but leveraging multiple clusters.
Great. Our next question is, how does VaultDB differentiate from other providers?
So VaultDB is in memory. We do persist, or we have snapshots of our data that can be configured and generated. We can actually have immediate consistency every millisecond if need be. We are an asynchronous and synchronous, have capability to retrieve data and load data. We are a shared nothing architecture. We do shard, so this allows us to distribute and organize a deployment out based on nodes, and having multiple nodes to be able to handle the throughput. But at the end of the day, we are designed to be able to do true real-time decisions. This means operational level solutions in which you are needing to have speed, throughput, and something that is doing compute as quickly as possible, and then be able to natively connect to a middleware stack of software like Kafka, Hadoop, and so on, to be able to move that information somewhere in real time. The last part of that is key. The old methodology of store and query is going to quickly go away for these real-time or true real-time use cases, where you're actually going to need to stream, make a decision, execute something on that decision. If I need to roll back, then I need to have that ability, right, the full ACID capability, but then be able to then move that information, that decision forward somewhere. That's how VaultDB is able to separate itself from everybody else in the pack. The true real-time decisioning capabilities, and configured in different ways, right, whether it's a document store or a schema-bound relational model.
Great. Our next question is there a functional difference between the Community Edition and Enterprise Edition?
There are some differences there relating to cross-data center replication and partitioning strategies, so that you get much more robust capabilities with the Enterprise version than you do with the Community Edition. In addition to the support, we're able to provide immediate support capability with the Enterprise Edition.
That looks like our last question.
If you all would, if you have any questions on this, or if you want to set this up, there is a GitHub link that we will provide, and you're able to reach me, or contact any one of us here at VaultDB, and we'd be more than happy to provide you a conversation on how VaultDB can leverage or can be leveraged in your organization.